I think, surprisingly, that my view on context is close to Sykes' view, was just described, has something like an upper level, and then it has a big ontology which has micro theories contained inside it. And it doesn't have a third thing in addition to the upper level plus the mid level, and then a third thing called context, which would be orthogonal to both of those. Rather, it views context in terms of choice of micro theory. Now, I think that I have a similar position. It's just that, unlike Psych, I think that our goal should be having micro theories which are all consistent with each other, because otherwise we're not supporting interoperability between data systems. We're supporting something quite different. And that's the kind of strategy which BFO was designed to support. And so I'm going to talk about three things. First of all, I'm going to talk about aspects of our thinking when BFO was originally being devised, which relate to some of the things which Michael was talking about a minute ago. And then I'll talk about what I think is the closest thing that we have to a context ontology, which is called the Environment Ontology. The Environment Ontology is focused on biological environments, but it can be applied much more widely. So one of the areas where we plan to apply it is in intellectual environments, where people who belong to, for instance, chemistry will talk to each other about chemicals, and they will all know what unionized means. And then other people who are talking to each other about cyber terrorism will also know what each other mean, what they all mean by specific technical terms in that domain. And those domains or contexts are then something which we hope to treat in terms of the environment ontology by treating intellectual aspects of an environment in much the same way that we currently treat aspects of an environment relating to things like climate and elevation and food and predators and so forth. But that's all a long story for the future. Today I'm going to focus on the environment ontology as applied in biology. And then at the end, I will talk a little bit about the environment ontology definition of an environment, which treats an environment as a system. And I will then have some speculative remarks about the relationships between systems and what some people like to call contexts. So the BFO began out of a series of interactions between myself and some of my colleagues in Buffalo and the world of geospatial informatics. And there is one very elegant contribution of geospatial informatics, which is called the region connection calculus, which is describing how different spatial regions can relate to each other. So they can be separate from each other, they can be tangential to each other, they can be internally tangential, and so forth. And the region connection calculus spawned a very rich collection of more complicated accounts of how spatial regions relate to each other, which one of my colleagues in Belgium at that stage applied to create an ontology of organisms, particularly human beings, for a large medical ontology project that he was involved in. This gentleman is called Werner Koisters. He's one of the leading figures in the BFO world. And he contacted me quite early on in order to find ways of applying the BFO ideas that we were slowly developing and the RCC ideas, which lay in the background, to the relations between objects and their surroundings, their environments. And so another RCC idea, which has been applied at great length in the geospatial informatics world, is to treat RCC not just in connection with relations between spatial regions, but in connection with relations between objects which occupy spatial regions. And that actually is the core of BFO. BFO has two levels, the region level and the entity level, or the non-region entity level. So objects like apples and oranges occupy three-dimensional spatial regions. Now, the other aspect of our early work on BFO had to do with granularity, and this too was inspired by the geospatial informatics world for reasons which will become clear. But in biology, it looks like this. You have two perspectives on the animal kingdom. You have the folk biology perspective, which isn't quite sure whether a fish is an animal or something else. And then you have DNA biology, which partitions the same space. And so we developed a theory of granular partitions, which were trying to do justice to the fact that both of these partitions are transparent to one and the same reality. It's just that they view this reality at different granularities or scales. And this is obviously a very common geospatial phenomenon. So we can view this object either at the level of country granularity, or at the level of region granularity, or at the level of department granularity. And we're looking at the same object then through three different perspectives. And I think that we emphasize at the beginning, much more than we do recently, that BFO is designed to be a multi-perspectival ontology. It's designed to support, for instance, different granular perspectives. So here we have four different granular perspectives on organisms, all of which may be veridical partitions of organisms, and BFO is designed to be able to work with all of these perspectives and also with any combination of these perspectives. So from this stage in our development, we were very fond of comparisons between BFO and cartography. So BFO could work with the world as viewed through different granular partitions. And then what we see when we look through these partitions is going to pick out different universals, different dimensions of invariance in the different domains. So this is the idea of map layers, which is a very common idea in GIS. The software for GIS deals a lot with map layers, which means viewing the same piece of reality through different perspectives. For instance, surveys or planning or real estate parcels or zoning, they all have different maps, but the maps could be maps of the same geospatial site on the surface of the planet. Now, this idea of multiple granularity ontology has been developed in great detail now by a group of materials scientists in Europe. They developed something called ENVO, which is based on BFO, but which goes into much greater detail and much greater scientific sophistication than the people working in the BFO realm on the biological side have so far attempted. So this is just BFO that you can see on your screen now. And if we zoom in, we see that there are two kinds of independent continuant in BFO. The independent is our word for what SOA calls self-standing, and continuant is our word for what SOA calls continuant. So there is at least one piece of agreement here. There are two kinds of independent continuants. There are material ones, which can be divided into objects, object parts, which are not objects themselves, called fiat objects, and object aggregates, which are collections of objects. And then immaterial entities are boundaries, sites, which will be very important in what follows, and spatial regions, which are self-evident, I hope. Now, what the MO people were concerned with was finding a multi-perspectival ontology for representing materials. The reason for this is that material scientists work with many different kinds of material models. Sometimes they view materials as solid lumps of material. Sometimes they view materials as collections of molecules. Sometimes they view materials as collections of atoms. Sometimes they view materials as if they were continuous, so that they are modeled in terms of differential equations, and so on. And if you have a lot of data coming from modeling using these different approaches, you need some kind of overarching ontology in order to be able to pull this data together and draw consequences from the fact that one and the same kind of material might be described correctly according to two different models in quite different terms, and you want to be able to combine the two descriptions in a coherent way. And they chose BFO as the basis for doing this unification. So these are the sorts of granular levels which they distinguish. We have the whole artifact, we have the component unit in the artifact, we have the smallest component unit within the artifact, we have then what they call beads, which are ways of describing bulk material entities, such as the wheel that you see there, in terms of those elements which give the most interesting mathematical possibilities for describing its behavior under different conditions. And those beads need not be molecules. They could be fictional components. Then we have molecules, then we have parts of molecules, then we have atoms, and then we have microphysical particles. They are building materials models at all of these levels of granularity. And so I hope this makes clear that BFO is designed as a multi-perspectival ontology, and you can think of that, if you like, as a multi-context ontology. One big multi-perspectival feature of BFO is that we have the continuant view, which just looks at the world of continuance, and we have the occurrent view, which just looks at the world of processes. And if you only believe that processes exist, which I believe is the case for John Sower, then you only need the occurrent view. You can just ignore the continuant view, and you can say things which are perfectly compatible with BFO. And then we have the bicategorical view, which tries to put those two views together. And then we have various views involving granularity differences and conceivably other kinds of perspectives that would work with BFO. Now, the second strategy or avenue I wanted to explore is the relationship between contexts and different sorts of environments. So I've already talked a little bit about this. We've done a great deal of work on biological environment ontology. We've done a little bit of work on social environment ontology. We want to extend that into other realms, including intellectual, but also military, for instance. So we start with a spatial view. This is the view that we developed very early on when BFO was still closely intertwined with a whole series of projects in geospatial informatics. We see environments as being a bit like holes. These are the kinds of words that you can use to describe environments, and this is a hole, for instance. And people are inhabiting this hole, and it's used for various purposes. It constrains behavior in certain ways. There are all kinds of systems within this hole, for instance, restaurant systems and policing systems and tourist guiding systems and bird seed selling systems and so on. And the people who go into this environment take advantage of the capabilities afforded by these systems which the environment offers. An indoor environment is also a whole, of course, with an H, where the systems include, for instance, heating systems and so forth. This is also an environment. This is an environment, and you get the idea. So there are four basic environment types. There are environments which are enclosed, such as an egg, a safe room in a building, a spaceship, an aircraft, and that's number one. Then there are environments which are half closed, such as a snail's shell. Then there are environments which are just flat, and the closure is entirely a matter of fiat. So a cow, when it's pasturing in a field, is taking advantage of an environment which has a certain surface elevation above it, but it's not. It doesn't have any physical boundary on the above the level of the floor boundary on which the cow is walking. And then finally, we have environments occupied by birds which never come to land, or which don't come into land for long periods of time. And there the environment is entirely a fiat boundary environment. And we can view these not just in regard to biology, but we can view them also for other kinds of interactions between organisms. So this is BFO again. And I'm going to talk now about where environments sit in this picture. And I already said that there are independent continuance, material and immaterial entities. And environments for BFO are sites. That's just the word we use. And a site is like a boundary. So you can see on this screen that zero-dimensional boundaries occupy zero-dimensional spatial regions. The North Pole, for instance, is a zero-dimensional boundary which occupies a certain point within the spatial region demarcated by latitude and longitude. Similarly, for one-dimensional boundaries, such as lines, the border between Colorado and Utah, and two-dimensional fiat boundaries, the surface of your skin occupies a two-dimensional spatial region, and then a three-dimensional spatial region is occupied by a site or by a body. So sites are holes. They are places where there is no body. Sites are the jewel of mountains. They are valleys. Mountains and valleys both occupy three-dimensional spatial regions. Now, we have lots of data on locations, which are then treated, at least in part, by BFO as data about sites. But we also have data about locations, holes, niches, habitats, and so forth, inside organisms, inside cells, inside molecules. So this is where the environment ontology covers environments at many different levels of granularity, using the same definitions of what an environment is. So these are some examples of sites. Your gut, your mouth, your ear, your eyes, all the cells in your body are sites, and many of the cells in your body are sites for bacterial infection or invasion, or indeed for hosting friendly bacteria, without which you would be dead. And we have many biological ontologies, as I think most of the people on this call already know, based on BFO, and quite a number of them are for dealing with different levels of granularity of biological phenomena. Now, as I think everyone in this call also knows, I am a big fan of ontology coordination. I think that there are far too many ontologies, and most of them are bad. And we need to try and focus on building good ontologies which work together on the basis of tested principles. And working together means being organized, I think, in terms of a hub and spokes approach. And the networking which hub and spokes approach methodologies imply is that ontologies, the picture here is slightly out of kilter with the green point, but never mind, imply that ontologies more towards the middle are then providing the terminological content which can be reused by ontologies which are more towards the outside. And in this way, all of the ontologies built towards the outside will have a larger opportunity for being interoperable with each other, because they all share the same ontology content derived from the hub, which is the top level ontology that you choose. And the most well-developed suites working today, most of them use BFO as their hub. And I could go into some detail about several of the suites here, but I'm going to be focusing just on the biological suite. So the other ones include a military suite, an intelligence suite, a suite for the United Nations, and an industry suite, which we're just beginning to establish. So this was the original diagram of the Open Biological Foundries Ontology Suite, created by the gene ontology, which is the yellow part here, which was a very, very influential early ontology, which is still the most influential ontology on the planet by an order of magnitude, I think. And influential here means in part reused by other ontologies, including the ontologies surrounding it in this picture. Now, the organizational principle for this suite is as follows. On the vertical dimension, we have granularity, which I've talked about a lot. And on the horizontal dimension, we have BFO. So we have continuants, which are either independent, which means they're objects, such as molecules, cells, or whole organisms, or dependent, which means that they are phenotypic qualities or functions or capabilities and so on, and then occurrence on the right-hand side, which are processes. And then we added the environment ontology. I'm not showing this today, but there is another layer now across the top, which is for populations and communities of organisms. And the environment ontology, of course, extends to that level of granularity also. But what we have here are the environment ontology focusing on single organism environments, cell environments, and molecular environments. Now, there are more than 300 ontologies reusing BFO at the moment, and most of them are still biological, but we have many ontologies, or increasingly many ontologies, which are outside biology. And the most recent systems, and specifically a project to develop an ontology for systems engineering. And the reason why this is relevant here is because the environment ontology, in fact, treats environments as systems. And so the environment ontology, the top level looks like this. And we're going to go through these 5 levels. So we start with systems, then we look at environmental systems, and so forth. And the definitions are very simple and not necessarily final by any means. So this is another view of that same ontology. You can see that the top level of the ontology is BFO. A system is just a material entity like the hydraulic system of your car, which consists of material components which are causally integrated. Now, that's clearly not enough yet, but it's used. That definition, or a logically equivalent definition, is used by very, very many standard sources on systems. So the final result of working on a good definition of system is going to look very much like that. And I guess the only conceivably controversial element here is to say that all systems are material entities. So some people say things like IBM has a system for making money. And that means it has a lot of people who know how to sell certain kinds of software or consulting or whatever it might be. I think that is a material system, that the system is made of those people. It may be made of bits of other material also, the laptops that they use to show their work. It certainly consists of their brains as one important element, but the people are the major parts of that system. And IBM hires people to become parts of that system. So I think virtually wherever we are tempted to think that systems might be non-material, we are in fact talking about things like people with brains, with skills, capabilities for doing certain things. And that's true of birdseed sellers in St. Mark's Square in Venice also. All right, now an environmental system has something called a disposition to environ one or more material entities. I did not choose the word environ. That's a word used in ecological science. And what environment means is that it includes within its site. So each system has a site, which is where it's located. A environs B if A is a site which includes B within it, and not just includes accidentally, but causally influences B. Now, most good examples of this environing relation are biological, But the example I give here is not biological, just to show that we're not yet doing biology. We're doing environments more generally. My example is a lost and found system in a railway station, where the system includes the managers who know what to do with lost and found items. The system environs the lost and found items, which are not biological. They're pieces of luggage and so forth. Okay, now ecosystem is an environmental system that really does environ living organisms. And then a biome, for the desert biome or the forest biome or whatever it might be, is an ecosystem that is determined by an ecological community. Determined means that if you take it away, it collapses. And again, I did not choose that word, but it's a word used in ecological science. So removing the corals from a coral reef will cause the ecosystem to collapse. And the ecological community is defined in the population community ontology as a community of at least two different species, where communities are connected by biological relations. And so we get a biome is determined by an ecological community. A microbiome, which is where all the bacteria in your gut are collected, a microbiome is a biome determined by microbiota. And I think that might be my final slide. So your gut is full of trillions of bacteria. They form a system called a microbiome, your gut microbiome. Now that is an environment or a context, if you like, for all kinds of activities which keep you alive, because they do a lot of the work which is involved in digesting your food. Yes, now there is a couple more slides. So this is how what we just talked about relates to BFO. So if you follow through the middle, you go from independent continuum to material entity to object aggregate to collection of organisms to the ecological community to biome to microbiome. And then this is just what I just said, but in a more visible way. So the blue, the dark blue is BFO and the light blue is population and communities ontology, and the other terms come from ENVO. And that's my contribution to context.